Good day. Today we are going to see an important chapter in the NEET physics session, that is system of particle and rotational motion. So the rotational motion, you know, linear motion versus rotational motion. Linear motion is the translation one. So the translational motion versus rotational motion. The rotational motion when it comes, what can tell you can tell about the example. Huh? Then? Clock. Okay, clock also an example. That is not a very good example. Very good example I need. First I need an example. Then I need very good fan. Fan is an excellent example for the rotational motion. Compared to what is for a translation motion? What is an example? Any example for translation motion? Translation versus rotational. Translation plus translational plus then translation plus rotational. Okay. So the translational motion. What is an example? Huh? Translational motion. Translational means the particle. If you apply anything, if you apply any electricity, it will move. That's all. Anything. What is it? Anything. Electric. No. If you apply electric current, something will move. What is that thing for translation? Translation. So translation versus rotational. So the translation versus rotational. Okay. Anything that you are applies electric. For example, car is not okay. That is not that much appropriate. Almost okay, but not that much appropriate. It's a electric train. That is the most appropriate. Electric train versus fan. So the electric train, what I am doing? This I taken you in the what is a thing of electric train? What is the current you utilized in the electric train? What are two types of current?
AC and
Huh?
Direct current and alternate.
AC and DC. Okay. What is used here in home appliances? AC. What is used in electric vehicle, especially electric vehicle? In railways, all the railways, they will use DC. DC. So the DC. Okay, that's we'll go later. Okay. So now why they using in DC? You know any idea? DC.
low expensive.
Huh?
Low expensive.
High voltage power. High voltage power. Here you have a low voltage because we don't want that much high voltage. We don't want. We want a home appliances. Home appliances what? Fan, tube light, AC, refrigerator, micro oven. Then this and all will come under home appliances. Just houses will be 1,000 square feet. Any house, 1,000 square feet, something like that. 1,000, not more than around 1,000 square feet. Okay. For that, what is the maximum utilized is only this.
240 volt.
No. That's different. That will go for later. Simple. I am having some house. Okay. Everybody is having house. Everybody around 1,000 square feet. 1,000 square feet. You will have fan, bulb, electric tube light, and refrigerator, washing machine. So everything will consume totally. It's a very low voltage consumes, which is very voltage consumes like something like 220 volt. That's why they kept at the electric box 220 volt. If you go for electric train, how many passenger it will travel in electric train? In electric train and passenger train, how many passenger will travel? More than 1,000. Not more than 1,000, nearly 1,000. Okay. So one person will have how many kg? Roughly 100 kg. So 1,000 into 1,000 into 1,000 into 1,000 into 100. 1,000 into 100. 1 lakh. So a train has to travel a kg of 1 lakh. So that's why they specify the ton. Luggage in the garage where it will carry the coal. It will carry the coal. Normally it will carry coal, cement, oil, etc., etc. So how many tons it will be? One garage will be.
110.
One garage will be how many ton? Huh? 1,000 ton. It will be 1,000 ton. It can carry maximum of 1,000 ton of one garage. So carrying passenger now is 0. It cannot carry. You can see that electric train cannot carry that much thing. Only diesel vehicle will carry. Diesel engine. Diesel engine is different from electric engine. Okay. Only diesel engine. So so I am needing more weight. More weight means more horsepower. So what I have to go for? I have to go for diesel engine for garage. Okay. For a passenger, I'll go for electric vehicle. So what is it now? What is the difference between garage and passenger? I need. Now what is the difference between garage and passenger vein? Passenger will run only by a electric vehicle. Okay. This will run. Garage need a heavy weight, so it will run only via through a diesel engine. So it's very. So what is the difference? What is the difference is it will need more horsepower. It means more horsepower. Electric cannot push one time. If you see that, if you notice that garage, it will not have one or two compartment you can take. You will not have one or two compartment garage. It will have at least something around 50 garage. They have 50. Okay. So it has to reach at the point at the given time. Okay. So 50 garage. One is how many ton it can carry? 1,010. So 50 into 1,000. 50 to 1,000. 50,000. So 50,000 ton it has to carry. So ordinary electric engine they will not carry. Okay. So only diesel engine can carry. So it needs the more horsepower. So that's the maximum thing. So beyond that you need not carry out beyond that one. So that's a maximum horsepower, maximum engine design. That's a maximum engine design. Okay. So now we come for this part. Okay. See what for we went for that? We went to that. Electric train. Yeah, electric train. Electric train that was running is via DC current. Okay. Electric train. DC. That's a DC. So electric train that is running via DC current. Here home appliances AC current because I need low voltage. That one is a very high voltage. Okay. So the power is difference. So in this scenario, see now that's also two example I am going to take. So what is the two example? Transitional motion and rotational motion. So transitional motion I will take the electric train. For rotational motion I will take the electric fan. So this fan I am taking, whether you can see a ceiling fan or this is a table fan. So you can take the table fan and have the that's all. You can switch on the electric current. So you are passing the electric current and fan is rotating it. Okay. Opposite of it, if the fan is rotated, what will you get? Somehow your fan is rotating. What will you get?
Wind.
If you switch on, you will get you are passing the electric current. So fan will rotate now. Okay. I am keeping this fan at 1,000 meter from here, from the surface. I am taking this fan. Okay. I am taking this fan. I am going to something around 10 kilometers. 10 kilometers sufficient, I think. 10 kilometers or 100 kilometers we can go. Okay. 100 kilometers I am going there. Okay. I am going to the mountain. I am going to something mountain. Here you didn't find mountain here, right? Where you can go for mountain? Where you can go for mountain? This is city. Here I cannot find any mountain here. Huh? Red Hills. Huh? Where? Oh, Saint Mount. St. Thomas Mount. Yeah. Not St. Yeah, St. Thomas Mount. Yeah, St. Thomas Mount, there is one mountain. If you leave this, then you go for Tambaram. Tambaram also one mountain is there. But it's not that much kilometer, I think. It will be hardly 1 kilometer, I think. Okay. I am taking this fan and keeping there. Okay. What will happen now? It will try to rotate itself. Okay. From there you can produce the From there, once it started producing the fan, once it start rotating the fan, it will produce the current. It will produce the current. So vice versa, okay. So now I am going for this fan itself now. So so anything that if I apply the electric current, so the fan will rotate. So yeah, so I want to do some various application, okay. Various application, for that I am applying the electric current. So in this similar scenario, so the rigid body, ideally rigid body is a body with a perfectly definite and undefinite shape, okay. Distance between any pair of the particle of such body don't changes. Then in the same scenario, what I am doing is I am taking one ladder, something like a slanting table. Yeah, this table is there, no? Slanting table. The table, let us assume this table, something a very big table from here to here. The table you assume say you assume the table. You assume let us assume you are having the table with slanting in direction. So if I have a slanting direction, I am taking one big parcel, okay. I am parcel and keeping that, okay. Now I am taking two experiments I am doing. First one I am keeping the parcel there, okay, which is the rectangular shape. So if I keep there, what will happen now? That will
come down.
It will come down. That's all. It's sliding and come down. That's all. This is the first experiment. Second one is I am taking the both football. It's a football. Football I am taking. I am keeping it. Okay. So what will happen now?
Roll and come down.
It will roll and come down. So this one is the translation energy because the particle is a rectangular shape. It is rectangular in shape. So it will pass through the translation energy here. Translational energy. The second one is football is the rotational energy. So it possesses both. Translational and rotational. So translational plus rotational. This one only translational. So this is the same scenario by which you can see that. So now in the same scenario, I am going for now this fan now. So fan, I am fan attached to the blade. So how many blade is there now? 3. So 3. So I am four possible. No. 3 possibilities there. 3 is sufficient. 3 we can take. I am attaching 2 blade. Second possibility, I am attaching 3 blade. Third possibility is I attaching the 4 blade. What's it? It's a design. That's all. It's a design. Nothing else. Okay. So the blade. So how many blade? First in experimental 1 is how many blade? 2 blades. To experiment 2 is 3. Experiment 3 is 4. So which will have the which you will feel that you will get a most hair.
Third experiment.
3 blades.
Third experiment. Four.
Second experiment.
Third experiment.
Second. Second.
It's a third. Number of blade. When the number of blade increases, you attach the speed will be the same. All the speed will be the same. 5 year maximum they will go for 2, 3 and 4. They will maximum. I think you might have seen there is a 4 also. There is a blade. It's not only restricted to 3. Okay, there is a 4. Now you can, if you increase the blade, that has what is the difference between that 2 and 3? 2, 3, 4. What is the difference now? You will R level is same. Okay, only it passing this medium, the space the hair is spreading will increase. The space where the how the hair is spreading, right? That will be increased. So the 4 will have the. No, what question I asked?
Which experiment gives more air?
More?
Air.
More air plus what is another advantage?
Widen. Spread.
Widen hair. So that if 2 blade gives the, if the 2 blades gives the narrow air, If the three blade gives the widened air, the fourth blade will give the more widened. So that if you increase the number of blade, the hair that we received will be widened. So that's why they are increasing the number of blade, and it is not restricted to 3. Okay, it is not restricted to 2 is very low. So the 2 you can neglect. Okay, you can neglect 2. Okay, 3, 4, 3 and 4. No, 5 is very rare. 5 is very rare. Only 3 and 4 only. The normal you will get 3 or 4. That's all. So that's a maximum attitude you can expect it. So now we go for 4 itself. Okay, maximum thing you can expect is 4. So I am going to have 4. So now 4, what is advantage? Air more hair you get, then widen. So the spreaded, it will spread the air more in the widen surface. So all the space you will get the air. So in this scenario, now we go for center of mass. So what is the center of mass tells that? What is the center of mass tells that? Center of mass I am taking as 2 point I am taking it. So origin with respect to origin, center of mass. Okay, center of mass. Center of mass, what it tells that with the center of how the mass is concentrated. If the mass is concentrated means center of mass with respect to, if I take 2 masses, I will take as mass 1 and mass 2. Now I am going for n masses. So how many masses will be now? N, no, how will you get n mass, but how many mass you will take? If it is 2 mass, you will take as m1 and m2. So if it is n mass means how many mass you will take? N. Okay, n. How will you take it now? That's okay. I know. Huh? N1? No. Nth mass you have to take as m1, m2 plus infinity up to addition, summation up to mn. So m1, m2 up to mn. So you have to take all the masses. Okay. Now I am taking one rigid, one body, one spherical body. I am taking it. Okay. Now rotational motion. No, you forget about fan. In the fan, you forget about. So in the fan, you forget about this. You forget about this fan. Okay. In the fan, you take spherical body surface. Okay. In spherical body surface, I am taking as how the spherical body surface will have. It will have in the sphere shape. It will have the circular. It will have in the. It's not a sphere. It will have in the circular, almost cylinder one, like, because almost no. It will be just a flat surface. It will be. You have to take small cylinder, something like that, with a flat. Okay, with a small height. Okay, you can take this simple this fan itself now. Okay, now how the center of the center body is, how is the center of center body now? How is the center body? Yeah, it will be in a cylindrical shape, not the sphere one. Okay, sphere is different. This is a cylindrical shape. To this attached the blade. The blade can be anything. Blade can be anything, irrespective of the blade. Blade, you need not worry about the blade, because you need not worry about this blade. Okay. So in the blade, it can be various shapes are possible. Okay. How many shapes are possible in blade? Blade. Various shapes. Various shapes of the blade. Huh? Blade. I'm talking about center of the body. Okay. Center of the body. I'm not telling. Okay. It's not then what a possibility I'm taking? What is the various possibility? What is the various possibility? Various possibility. You understand my question? I am having the center body. Okay, you forget about center body. Okay, center body you forget. Okay, now we go for blade. What is the various possibility that can possible in the blade of the fan? What? Blade. Shape. I am asking the shape. everybody is blinking? For everything you are blinking. Shapes. I am asking various shapes of the blade. Huh? Circle. Circle எப்படி வரும்? No. Normally it is meant for spherical. No, not rectangular. Normally recommended for rectangular. Okay? And rectangular shape only. They want mostly they recommended for rectangular. Okay? Then they go for something like okay. Then they go for triangular in shape. Okay? That attached to the head. Okay? Then one more shape is possible. Any shape is possible. Huh? Yeah, that will come in a triangle. Rectangular, okay. Triangle, huh? Mostly they recommended is parallelogram. Okay, in the blade that is attached towards that body, it will in the upper portion. Okay, it will be the upper part. The lower part which is away from the center of the body, that the blade will be lower part. The lower part will be somewhat upper part and lower part. Upper part they will attach to the body of the fan. Okay, and the lower part will be somewhat to be towards the sliding down. Okay, sliding down. So how much sliding down? It will be a difference of around 10 centimeter. Not that much difference. Okay, slightly 10 centimeters or less than around 10 centimeters. It will be sliding down. You understand the blade now? You understand the question now? You understood or not? No, you did not understood. You are not understood. First one is rectangular in shape. That everybody knows that. Okay. Second one is triangular or leaf-like shape. Okay, leaf or you can take as triangular, something like that. It will be like cone shape, something like that, which is almost like a cone or rectangular, something like that. Cone means top layer, bottom layer they will attach to the body. Top layer will be away from the body. Okay. Now this is something like parallelogram. Parallelogram means it will be like parallelogram means how the parallelogram. First you have to tell that parallelogram, how the shape of the parallelogram will be. Parallelogram will be just slight bending of rectangular. The top of the rectangular will go, that's the left side. Right of the bottom of the layer will go downsides. Okay, this is the parallelogram. And how it attached to the parallelogram means it will be slightly bended in the center. Yeah, that is, if the center is bended means what will happen? The top layer will be attached to the body of the fan. Okay, so you don't have when the bottom of the bottom or lower region of the things will be slightly downward. Will be slightly downward or bended at the center point. So when it's bended at the center point means slightly downward. You can't find it. It will be slightly bended. The difference will be normally not more than 10 centimeter or 5 centimeter, something like that. So you can't find it unless otherwise you viewed it properly. So this is what recommended and why it is so. Why it is so and why it is so. This is what recommended. Why it is so. Pass air see, once you switch on the fan you will get air.
Fast air supply.
Pass the
Fast air supply.
fast, not for fast air supply. Wider, not wider. The density of air you are getting will be more in the density of air. Okay, more air you will be getting. Okay, more air you will get it at the option number. Option number 3. 3. That's why they recommended. But it's very expensive, so nobody will buy it. That is very expensive and nobody will buy it. Normally they will go for option 1 and option 2. So the more air you are getting from this option 3. So why are you getting more air? That's my question. You understand my question now? Yeah, correct. Because of shape only you are getting that. That's why that they arrange that shape. That shape only give that exactly. Why that getting more air now? That density. Density means that here I am getting some air. Once I am switching on the data, the density will be more. That's this for a given area that air will be more. So why there more air? That's why I'm asking why the design is that, third design is that, why it's more air? Because of huh? How the shape helps in the thing. Shapes help the things means curve, it's a bended, okay, bended. So bended means that's it, they recommended for the, that's because of curved shape which is bended, that it will the waves which is acting on the hurdle, which the water air which is acting, there is no hurdle at all. When the blade rotates, there is no hurdle, so that you will get more density of more air or density will be more air or density will be more. Okay, so this is what they recommended. So now we come for the body of the fan. So body of the fan, now you need not worry about the blade part. Okay, so now the blade part is there. Now I am taking the two mass to the center. So this is the center with respect to M1 and M2. With respect to origin, it takes X. With respect to center, it is X. X1, X2. X1, X2 is from the center of origin. From the center of origin, it is X1 and X2. So if it is so, then what is total center of mass will constitute the X is equal to M1 X1 plus M2 X2 divided by M1 plus M2. So if it is that is so, when there is two masses are equal, what will happen now? X is equal to M1 X1 plus M2 X2 divided by M1 plus M2. So M1 is equal to M2 means what will happen now? M1 plus M1 is equal to M2 is equal to M. So what is an M? So M plus M is equal to 2M. Here it is M x1 plus M x2 divided by 2M. So is equal to x1 plus x2 divided by 2. So if it is for now we can go for n particle. N particle means M1 x1 plus M2 x2 up to Mn xn divided by M1 plus M2 up to Mn. So that means I am taking the n particle. First I am taken 2 particle. Now I am taking the n particle. So n particle means what will happen now? If I take the n particle, so the x is equal to, what is the x now? What is x? X is the center of mass. No, what is x? X is the center of mass. Center of mass of 2 particle. Now I am taking center of mass n particle. So if I take the center of mass of the n particle, what will happen? N particle, so M1 x1 plus M2 x2 up to Mn xn. Mn xn divided by M1 M2 up to Mn. So finally I will get this value. Now it varies the 3 dimension. So for x axis it is like this. Now if I go for y axis what? Now if I go for y axis, center of mass will be y. Y is equal to mi for 2 particle I am taking m1 y1 plus m2 y2 divided by m1 plus y2. Now I go for in the y direction I am going for n particle. So m1 y1 plus m2 y2 up to mn y2. M1 y1 plus m2 y2 up to mn yn, then divided by m1 plus m2 up to mn. Okay, then then again I go for z direction. Z direction you have to tell me now. No, you tell me. Yeah, you tell me. For z direction. Z direction. Z direction Z is equal to M1 M Z is equal to what then? Z is equal to M1 Z1 plus for two particle M1 Z1 plus M2 Z2 divided by M1 plus M2. Now I go for Zn. Zn means n particle. So it will be how, what will be now? M1 Z1 plus M2 Z2 plus up to summation Mn Zn divided by M1 plus M2 plus summation up to Mn. Yeah, so is it clear with you now? Okay. Okay, you tell me if so. Everybody tell me for x, y, z for nth particle. Anyone tell for x1, x, and anyone tell for y, and anyone tell for z. Who will tell for x? Who will tell for x?
X is equal to M1 x1 plus M2 x2 up to Mn xn by M1 plus M2 up to Mn.
Mn. Okay. X is over. Now y. Who will tell for y? Who will tell for y? That's all.
Y is equal to
Ah.
M1 y1 plus M2 y2 up to n by
No, up to. No. What is first? Wait. First, what is first one?
y is equal to
Ah.
M1 y1 plus
Ah.
M2 y2
Ah.
up to
Up to.
Mn yn
Ah.
by
By.
M1 plus M2 up to Mn.
Okay. Y is over. Or then x is over. Y is over. Who will tell for z? Who will tell for z? Who will tell for z?
M1 z1
Ah.
M2 z2 up to Mn z.
Up to no.
M
M1. M1.
M1 z1
Plus.
M2 z2
Ah.
up to Mzn.
That's why I asked you. Okay. That's why I asked you.
Mzn.
Yeah? No. MNZN. MNZN divided by
M1 plus M2 up to Mn.
up to Mn. Okay. Okay. Anyone will tell for y? Anyone can tell for y? You want? Okay.
M1 y1 plus
Wait. If y is equal to M1.
M1 y1 plus M2 y2 up to Mn yn.
Mn yn divided by
M1 plus M2 up to Mn.
Mn. That's all over.
Black color.
So this is the. So I am taking now z. Okay. X, y, z. Now I am taking for 3 particle. I will tell myself. Okay. Mi. Is that right? Is that is that? You can take as x itself. Okay. Mi xi plus m2 x2 plus m3 x3 divided by m1 plus m2 plus m3. Now I am taking 3 masses. Now I am taking masses. All masses are equal. So m1 equal to m2 equal to m3 equal to m. So now if you substitute all this value, what we will get? M1 m into x1 plus m into x2 plus m into x3 divided by m1 m plus no not m1 m plus m plus m. So I will get 3m. So again I have to make the cost distribution. So I will take m outside. So if I take outside if I take m outside, it will be m into x1 plus x2 x3 divided by 3m. So what will be? It is equal to x1 plus x2 plus x3 divided by 3. That's all. So for 3 masses. So you have to calculate you can calculate for n masses also. Okay. So total x is equal to summation of mi xi divided by m. Total number of m. Okay. Y is equal to summation of mi yi divided by m. Z is equal to summation of mi zi divided by m. So the total center of mass, if you make all the total, this is what, okay. So now we go for
The sound in the control panel.
Yeah, then again x is equal to summation of delta mi xi divided by delta summation of delta mi. Y is equal to summation of delta mi yi divided by summation of delta mi. Z is equal to summation of delta mi zi divided by summation of delta mi. So these are the various concentrations that we seen. Now we go for, this is a center of mass we going. That is, center of mass is the one where at the center what will be the mass, because that mass will be the where will be the coil. Okay. Now again we come for the fan. Again we are coming for the fan. No, we concentrate in fan only, coil of the fan only. Okay. Okay. First you have to see the why we concentrate. What we are discussing now? What we are discussing? Huh? Center of mass. Center of mass we are discussing, but what? Why for we are discussing? Yeah, rotational motion. For specifically rotational motion. Okay. For the rotational motion, we are discussing the center of mass. Center of mass is the one where we need to concentrate. Okay. So the center of mass. All the concentration, the blade. That's why the blade. For example, I am taking four blade I am taking. Okay. 3 experiment I am doing. Okay. In experiment number 1, I am taking 4 blade. In experiment 2, I am taking the 4 blade. In experiment number 3, I am taking also 4 blade. Okay, 4 blades I am taking it. 3 experiment I am doing, 4 blades I am taking. All the experiment I am 4 blades. Okay, so I am increasing the weight of the blade. Okay, weight of the blade. So which will have the highest blade is experiment 3 has the highest blade, and experiment 1 has the thin one. Lowest blade or thin one. The thin, it is very very thin, and the blade thickness I am increasing. Okay, which is in the experiment number 3. Okay, now I am switching on it. Okay, okay, the center of the body shape of the bodies, all the 3 will remain same. Now which will have the highest density of the air? Huh?
Experiment 1. Blade with thin.
So that means you are telling that experiment number 1. So everybody is supporting it? No, everybody is supporting it. Everybody is supporting it or not? Everybody is okay. Who is lifting that? So experiment number, okay, majority telling experiment number 1. So I am telling us experiment number 1. Who is supporting experiment number 1? Who is going for another option? So it should be 3 options, that's all. 1, 2, 3. 1, 2, 3. So who is going for option 1? Okay. Who is going for option 1? Okay. So okay, raise your hand. Who is going for option 1? Who is going for option 1? Who is going for option 1? So everybody is going for option 1.
No, those.
So then what option you are going? So which option you are going now? Option number 3. So you are only person going for option number 3. Okay. It's option number 1. It's option 1. It's not about the thickness of the blade. It's about the thickness of the blade. That's why we are discussing now center of mass. The mass that is concentrated inside, that will contribute to the speed of the thing. That will increase the thing. That is the blade is just an output. It should be the minimum. For example, I am placing, now what I said, thickness, okay, 3 thickness I have taken. Thickness, second experiment is just thinner, thick, something thick. Second experiment is more thicker to that. The third experiment I am taking as third experiment I am going for still more thicker that. Okay, so the thickness of the experiment number 3 will be more length, more not rigidity, not like that. Okay, wider, not wider. Something we can take length is constant. Okay, length is constant, breadth will increase. let us assume we increase 3 in all the 3 experiment. Experiment number 3 will have a more breadth. Okay, experiment number 2 is having lower breadth is the lowest one. Experiment 3 is the lowest breadth. Okay, so 3 experiment we did it, and we have found. So what they found it, only the lowest breadth. Lowest breadth will have the highest density, and is the density. Okay, now in the same scenario, if I increase the lowest ring, still I am increasing the lowest also. So still I am increasing. 2 experiment I am doing it. Okay, I have taken option number 1. Okay, so again I am going for 2 experiment. I am taking one breadth which is lowest one. I am taking another experiment which is still lowest to the one. Which will have highest one? Highest density of air. I am going to experiment. I am taking experiment number 1. Experiment 1. Okay. Experiment 1 I am taking it. I am taking that flat blade. I am still designing something very lower breadth than the experiment number 1. So half of it. Okay. Half of the breadth. So half of the breadth if I go, then I am taking 2 experiment now. Experiment number 1 is breadth is lesser than the experiment number 1. So experiment number 0. Experiment number 0 you can take. Experiment 0. Experiment number 1. Experiment number 1 has the breadth. That breadth is half of the experiment number 0. So which will have the leave it above option number experiment number 2 and 3. That we don't want, because we confirm the experiment number 1 is the highest density. Now which will have the still more high density?
Experiment 0.
Experiment 0, because if increase it's not about the breadth, it's least about we are least bothered about the breadth, because we are the breadth that we are the flange blade that we are taking is just an output of the spherical body of the fan. Okay, we are concentrating only at the center of the mass. Center of the mass that makes the contribution to the more increase the more increase to the density of the air. If the thickness is there, just nothing, it's almost negligible. Okay, whatever the thickness will be there, but not that much difference, but still okay. Not that much difference, but still okay. Okay, so this part 1 only. So now we going to see if the center of the mass if the center of the mass now we are going to see. Now again we going for 3. So now we are going to concentrate on the center of the mass. So what the center of the mass center of the mass tells that if we increase the speed means you will find the density of air will be the more. Density of air will be the more or the most. Okay. So in this now we go for now we go for the motion of the center of the mass. So how should be the motion of the center of the mass? So mr is equal to summation of mi ri is equal to m1 ri m1 r1 plus m2 r2 up to m2 up to summation of mn rn. Okay, so this is the total variation, and now if r is varies with respect to time, it is m into r dr by dt is equal to m1 into dr1 plus dt plus m2 into dr2 by plus dt up to m2 up to mn drn by dt. Now if this what is dr by dt? Dr is dr by dt. R is the distance. So distance by time is equal to distance by time. Yesterday only I teach, no? dr by dt. R is the distance. So distance with respect to time. So dr by dt is dx by dt. Not dr. Normally we will take as dx only. Yeah, dr. Here you can take as taken as dr. You can take as dr. You can take as velocity. Velocity. So dr by dt is velocity. It's not about r. You can take as s. You can take it as a, b, c, d, f, g, h. Everything you can take. Nothing is bothered. Only thing, what is the thing? So the nomination is d. Here they taken as dr. That only you have to take. Okay, what they given only you have to take. So dr by dt is equal to v. So that is mass into velocity is equal to m1 mi vi plus m2 v2 up to mn vn. Okay, so velocity. Okay, then so the now rate of change of velocity So rate of change of velocity. So mass into dv by dt is equal to m1 dv1 plus d2 plus m2 v dv2 plus d2 up to mn dvn plus dt. So dv by dt is equal to dv by d2 dv by dt. Acceleration. So ma is equal to m1 a1 plus m2 plus a2 up to mn an. Acceleration. So then now we comes the first what we have taken first we have taken is mv is equal to m1 v1 plus m2 v2 up to mn vn. Then we had what we drawn mv is equal to ma is equal to m1 a1 plus m2 a2 up to mn an. So what is this for? How many particle we are taking it now? How many mass we are taking this? How many mass we are taken it? Yeah, nth mass. N masses we are taken it now. N masses we have taken it, and we are concentrating how where we have to apply the electric field. Okay. So if I apply so now I am taking okay, I am taking the electric field. Okay, I am taking the electric field. So when I switch on the thing, when I switch on the switch on, immediately fan will rotate. So where will pass to the electric field now? Where you will pass the electric field? Yeah, to the coil. Okay, where the coil should be? Center. If you pass, if you keep the coil at the terminal of the blade, blade terminal, will the fan rotate?
No, sir.
So if the center of the blade, terminal of the blade, center of the blade, will fan rotate? No. So only third option is only center of the blade. So center of the blade or to the coil. Okay. So only in the center only we have to concentrate. So now what we take that m is equal to mass into acceleration is equal to m1 a1 plus m2 a2 up to mn an. So then mass into acceleration is equal to force. Okay. So ma is equal to f1 plus f2 up to fn. Okay. So the total mass into acceleration is equal to total external force. The center of mass of the system of the particle moves as if all the mass of system were concentrated at the center of mass. All the external force were applied at that point. That is where you have ma is equal to
M1 A1 plus
no. Ma is equal to force. Force is directly force of force is force equal to m into a. That is mass into acceleration. So if I apply a force to it, if I apply a force, I can rotate by hand and son. You are passing the current. Okay, fan is rotating. Now no need for that, right? That the current was invented almost a century back. When the current was invented? Who invented the current?
Edison, AC motor and DC motor.
Who is invented DC?
Edison.
Edison invented AC. AC.
Tesla.
Huh?
Tesla was alternative current.
Edison. No, Edison discovered by AC.
Tesla, sir.
AC. First who discovered DC?
Edison, sir. Edison or DC.
Edison வந்து Edison வந்து அவரோட ஸ்டூடெண்ட். He is a student of Nicholas. நிக்கோலஸ்ன்றவர் தான் கரண்ட் கண்டுபிடிச்சார். அவர் கண்டுபிடிச்ச ஸ்டூடெண்ட் அவரோட ஸ்டூடெண்ட் தான் is a student of Edison. He only got Edison, AC. So okay, you find out who is current discovered AC and DC. Okay, DC and AC, which year they found out? Okay, the century almost a century. Oh, see, I forgot what I asked. What question I asked? Before that.
In the century.
Which century they found out the current? Who discovered current? Which century they found out current? AC, DC. Okay? AC, DC. So, see, if you are passing the current, the fan will rotate. But it's not like that. I can make a fan, I can rotate my hand itself, right?
Hand will
Hand will, I can rotate in the hand, okay? So if I rotate in the hand, what will happen? Will it rotate or not?
rotate, sir, but not faster.
No, just I don't want that until I don't want. Will it rotate or not? Yeah, it will rotate. Yeah, I can apply certain force from my hand. Okay, so that instead of me only, a man can rotate for a force for a long time. Okay, so that's why the current is replaced by the current. So everything things in your life should be simple. That's all. So all humankind has to survive. So that's why the current was introduced. Okay, so current was introduced. I am giving the force. So what is the two types? So now I am applied with the now I have applied. Now I can apply. Okay. Now I can rotate the fan. Okay. Can a baby can rotate the fan? No. So you need a minimum force. So minimum force you need to rotate something. Okay. So then only the baby. Okay. You know everybody. A 1 year baby or 2 year baby or 3 year baby, and nobody can rotate the fan with the fan. So I need to rotate it very fast. Okay. I need to rotate the fast. Whether it's fast or slow, some rotation has to take place. Whether it is fast or slow, I am least bothered about it. So I am rotating the fan. So can I rotate it or not?
Yes, sir.
Yeah, I can rotate it. I can rotate at least not for a long time, for short period of time I can rotate. So something I can make rotation. So you need minimum force that is ready to apply. So that is force is equal to mass into acceleration. So that the force. Now comes the current. So the same technique can be applied to the current. Instead of me, I can rotate for a long time. Okay. Everybody knows that. Nobody can rotate for a long time. Okay. Short period of time. At least for 5 minutes. At least for 5 minutes or 10 minutes. Something I can rotate 5 minutes. But the current can rotate it for infinity. No time limit. So that's a force. Force is equal to mass into acceleration. When we started? 9:30.
940, sir.
9:40. Almost 9:30. No? Okay. Now linear momentum. Linear momentum is equal to mass into velocity. Force is equal to rate of change of momentum. Rate of change of momentum with respect to time. So the momentum is equal to mass into velocity. The total momentum of the particle is equal to product of the total mass of the system and velocity of its center of mass. So dp by dt is equal to mass into dv by dt, which is equal to mass into acceleration. Dp by dt is equal to
Mass into
dp by dt is equal to external force, which is F. Vector product of the two vectors. The two vectors you can take. Okay, two vectors you can take two vectors you can take by which vector A and B. Okay, with the angle difference is theta. Now if you take the two vectors which is in the x direction and this one in the y direction, and angle between it's theta. So the third vector is C. Which direction you can expect? Two vectors A and B. C, C is the third vector. Which direction you can expect?
Z direction.
It should be Z direction, because A and B, A vector in x direction, B direction is y direction. Angle between them is theta. So if the angle between them is theta means what will happen? Angle between them is theta means which direction you can expect? Z direction. So A cross B is equal to A cross B is equal to minus B cross A. That is the A into B is A cross B, that is x and y direction, into B cross A. B cross is equal to minus B into A. And so I into I is equal to 0, J into J is equal to 0, K into K is equal to 0. Then I into J will be I into J, that is I is which direction? X axis. J is y direction, equal to is a K. K will be should be in the Z direction. Now we go for angular velocity and angular velocity. So fan is rotating now. So what is the velocity? Any fan rotates means you have to take the angular rotational motion. Okay, rotational motion will be, now your velocity is angular velocity. So the angular velocity, linear velocity is given by r omega, that is linear velocity is given by equal to r into omega, where r is the radius, omega is the
Radian by time.
no, just omega, this one, omega is the angular velocity. So linear velocity is equal to radius into angular velocity. Omega is equal to d theta by dt. Omega is equal to d theta by dt. Then now we go for angular acceleration. Angular acceleration is given by alpha is equal to d omega by dt. Momentum of force is given by torque or couple. So the torque is given by r into f. Torque is equal to r into f. What is torque now?
Momentum of force.
Momentum of force. Okay, momentum of force is equal to r into f. What is r now?
Radius.
Radius. F is the force. Angular momentum of the particle. So the angular momentum of the particle is given by torque is equal to dl by dt. What is dl by dt is, L is the linear momentum. So the linear momentum with respect to time. Then total momentum is equal to L1 plus L2 up to Ln. So how you can write now Ln? L is equal to L1 L2 up to Ln. Now how will you write this now in total summation? In the summation part, how will you write? Summation of I is equal to 1 up to n, the summation of L I. Li, that means what?
L1 plus L2 up to L3.
L1 plus L2 plus L3 up to Ln. So that Ln you can take it as summation summation I is equal to 1 up to n. That means I is the least value, n is the I is the 1 is the least value, n is the maximum value, minimum value means below 1 is not possible. That is I is equal to 1. Then n is the maximum value. That is the maximum value. Below above that is not, nothing is possible. Torque is given by dl by dt, which is rate of change of momentum with respect to time is the torque, which is external. So the rate of change of angular momentum of the system tickle about this point is equal to sum of external torque. Okay, then dp by dt is equal to f external. That is dp by dt is equal to f external and dl by dt is equal to torque external. Now again we go for equilibrium of the rigid body. It will take time. Do you need break? Still, it only half only we covered now. Huh? Only we covered half only. then equilibrium of the rigid body. Okay, in the equilibrium of the rigid body, what will happen is, for example, I am taking the water bottle. Okay, water bottle I am taking it. What I am to do? How will I have to open the water bottle? In circular thing motion. Okay, if I apply the pressure opposite direction, it will close in. If I open it. Then if I take like this, means what will happen? Huh? It will not? Yeah, it will not open. It will not open. So it will not open. Okay. So you have to apply the in the certain direction. Okay. So in the certain direction, if you have open with the respect to center of in the with open to the center, that's a main center we are keeping it. Okay. If the main with respect to main center, we are opening in the certain direction. So which direction will open and which direction will close? No, you not say like that. Which direction?
I direction.
Ayya. Which direction?
Right. Opposite.
What is this and what is that? Clockwise and anti-clockwise. So you have to close it in the clockwise, open in the anti-clockwise. So you have to tell that only. It's not about which thing. So anything we are opening in the anti-clockwise. So if I open in the I am opening in the anti-clockwise, I am closing in the clockwise. Yeah. So with respect to the center of the mass. So with respect to center, I am taking as a thing. With respect to center, I am taking the cap. Center I am taking and opening with respect to the center. Okay. So now I am not opening the any of the lid as such like this. So if I open any of this like this, what will happen?
It will not open.
It will not open or it will break, something like that. So if this is the torque, that is the momentum of the force, the torque, the force. Now this is now I am opening it. So when I open it, what is the force I will apply now? I am opening it. Okay, force I am applying. What is the force I will apply? Yeah, torque. It's not a force I am applying. I am not applying any force to it. Okay, I am applying the torque to it. Why the torque? Why not force? Yeah, circular motion. It's in the circular motion. For any circulation motion, you are applying that force that is called torque. And any force they are applying in the linear motion. Okay, that is called. No, that's a force. That's a force that you are applying for the linear one is a force. Okay. Now I am applying a fan. Fan I am taking it. I am applying physically a force to it. So what force I am applying?
Torque.
Yeah, torque. I am not applying a force to it. I am applying a torque to it. Okay. So the torque I am taking it. I am taking the torque. Okay, and stating it for. I am stating it. I am applying for torque. I am taking the various particle. I am various position of the torque. I am taking it for two torque. What is the summation? 2 torque. So torque 1 plus torque 2. Torque is equal, total torque is equal to torque 1 plus torque 2. For n torque. For n torque up to torque n. Okay. So how will you write the summation now? Now first you tell me for what is the torque for the n push n particle. Torque is torque is equal to. You understood or not? No, you have not understood. Torque that is applied to the n particle. Okay, in the rigidity body. Okay, torque. How many torque is there? N number. If there is n number of thing, how total torque is equal to how many total number? How will you calculate? Yeah. Who will tell now? Who will tell now? Who will tell now? You understand the question now? I am applying the n number of torque to the rigid body. Okay, rigid body. Okay, I am applying n number of torque to the rigid body. Okay, now I have to calculate the total torque. So total torque is equal to torque 1 plus torque 2 up to torque n. Torque 1 plus torque 2 up to torque n. Okay, now how will you write this torque in the summation?
Sigma
No, no,
to
no.
1.
Okay, you tell. You tell. How will you write the total? You understood my question? Okay, the motor is there. I am applying the N torque. Okay, N torque. How first? No, first you tell how will you write the total torque. Total torque is equal to. First you tell the total torque. Total torque. Total torque is equal to how many torque you are applying there? There are no N. No N. N torque I am applying. Okay, N torque I am applying. So how will you write the total torque now? Now total torque is equal to. No, it's not a torque N. Torque 1 plus torque 2 plus up to summation up to torque N. Now you write the in summation part. How will you write in the summation part? Summation of
Torque 1 plus torque 2 summation of.
No, summation. In the summation, how will you write it? That is, the summation means first total torque. Total torque is equal to, first how will you write it? Total torque is equal to torque 1 plus torque 2 up to torque N. That's all, that is over. Now we have to write the summation. So summation of I is equal to 1 up to N torque I. So total torque is equal to summation I is equal to 1 torque I N. So you understood now? You did understand? You did understand? First at least first you understood, no? Torque 1 plus torque 2 up to torque N. Now we have to write the total in the torque in the total summation. That is, for N, that is one mode of writing it. This is second mode of writing it. That is, you can substitute N value. N could be, if you write this like this, torque, then you can substitute N value. You can substitute N is equal to 1, N is equal to 1000, N is equal to 1 lakh. Anything you can substitute. So how will you write this thing? You have to write summation. First you have to write summation. Okay, I is equal to 1.
Up to N.
No.
Up to N, sir.
Summation I is equal to 1 torque N, torque I to up to N. So what is N and what is 1 now? What is 1 and what is N? What is torque I? Torque I is the total value. Okay. What is I is equal to 1? What is I is equal to 1 and what is N? I is equal to 1 is the least value or minimum value, or minimum you can take. Then up to N. N is the what? Then what is N is the maximum value. That's all. So N is equal to maximum value. I is equal to 1. Okay. N is equal to the maximum value. So maximum. Now I am taking only one torque. Okay. Now I am taking only one torque. Then what will substitute for the N? What you will substitute for the I is equal to 1. Okay, I is equal to 1, that is minimum value, and N up to N. Now what will substitute for the what will substitute for the N? I want only one. I am taking only one torque. Okay, I am taking only one torque. Okay, torque I is equal to 1 up to N torque I. How many value? Only 1. So what will substitute for N now?
Torque 1, sir.
Huh?
Torque 1.
Torque?
1.
No, torque 1. No, I am telling you, you are just telling repeated. You are telling repeated to me. I am taking total value is 1. Okay. What will substitute for N?
N equal to 1.
What is substitute for?
N equal to 1, sir.
Okay, I am going for 100. Now what will substitute for 100?
Equal to 100.
Then I am substitute for N equal to 100 means how many value you will get?
100 values.
For one value, for one?
1 values.
For here it is?
N
N is equal to, no, if you substitute N is equal to 100, how many value you will get?
100 values.
Okay, okay. Then in the same, torque is equal to torque is equal to I. Okay, torque is equal to I. So I is equal to 1 torque I summation n. So you can substitute for now 1, 100, 1000, anything you can substitute. Okay, anything you can substitute. So now okay, now I understood everybody.
Yes, sir.
Huh? Now you understood. Okay.
I
Are
equal to 1 up to n, sir.
I equal to no, it is not I equal to 1. N value da. Only you have to substitute n value. N value should be 1. N value should be 100. N value should be 1000. Anything is there. Anything you can substitute. Now same thing varies. It's not about the one thing. Okay. So total torque, that means now where we left, torque summation I is equal to 1 to n torque I to torque I. Okay. So this is the value. So if it is x-axis means what will happen? X-axis, y-axis, z-axis. How it will be now? X-axis, y-axis, z-axis.
Torque
X-axis.
Torque x.
Torque?
X.
Torque? X-axis, y-axis, z-axis.
Torque I, torque j, torque k.
Yeah, if it is in the x-axis, the torque will be x-axis. Y, it's in the y direction, it will be y-axis. Okay, and that is what my question. What is my question? Total torque. Total torque. How will you write? How will you write? What is the total torque? What is the total torque?
Torque x. Sir, torque x plus.
First, no. First total torque is equal to, what is the total torque?
Torque 1 plus torque n.
No, that's okay. That's okay. Second one. What is the second one? Torque is equal to. No, any one person you tell. Wait. Any one person. Torque is equal. Total torque is equal to what?
R into F.
No. That is different. Now just now I told no.
I1 up
I is equal to.
I1 up to torque IN.
I is no. I
equal
n.
to 1 up to n torque I.
Huh? I is equal to.
1.
Total torque is equal to what? Total torque is equal to.
Sigma.
Summation. No, I is equal to 1. Summation I is equal to 1 up to n torque I. Summation torque I.
சார் ஒரு ரிக்வெஸ்ட் சார் அது மட்டும் போர்டில் எழுதுங்க சார் ஏன்னா நிறைய போடணும் சார் மாற்றி மாற்றி சொல்கிறேன் எல்லாருமே
Total torque is equal to I is equal to 1 n torque I. Okay, if it is x-axis, what will be the total torque in the x-axis, total torque in the y-axis, total torque in the z-axis. Total torque is equal to
Summation I equal to 1 up to n torque IX.
Torque Ix. Then y-axis.
Torque I.
Torque
So, first this you have to tell. Summation 1 up to n torque Iy. Z is miss. Is now you know x and y you know. Is it?
Summation
I equal to 1 up to n torque I.
Iz. Okay. That's all. Yeah, okay. Okay, 5 minutes break. Will 5 minutes? No, 5 minutes break.
Live.
That's 5 minutes break. You could tell me. You tell them they will come.